18. Nucleus of a radioactive element A are being produced at a constant rate alpha. The element has a decay constant lambda. At a time t equals 0, there are n naught nucleus of this element. The question is asking calculate the number n of the nucleus of A at time t. If alpha is equal to 2 n naught lambda, then calculate the number of nucleus of A after one half life of A and also the limiting value of n as t approaches infinity. So for this one, I am saying the question is stating that a radioactive nucleus of A is being produced at a constant rate alpha, and then the rate of decay is equal to lambda times n. So over here we are talking about the production of this radioactive nucleus, and over here we are talking about the rate of decay. So rate of production and rate of decay are discussed. Now at a time t, n is the number of the radioactive material. So if n is the number of the radioactive material, so at a time t we can say that the rate of formation of the nucleus A, that is dn by dt. So over here I am writing the rate of formation of nuclei A can be written as dn by dt, and this dn by dt can be written as alpha minus lambda n, that is rate of production minus rate of decay. So from here we can solve this equation. So I can write it as dn upon alpha minus lambda n is equal to dt. So now we are integrating both sides. Suppose at t equal to 0, the number of n is n naught, and at a time t the value is n. So on solving we obtain the value of n as 1 by lambda alpha minus lambda n naught e to the power minus lambda. So this is the value of n that we obtain on solving this problem. Now in B part the question is saying if alpha is equal to 2 n naught lambda, then calculate the number of nucleus of A after one half life of A, and we also have to limit the value of n as t approaches infinity. So over here I can say that we just need to substitute alpha is equal to 2 lambda n naught and t approaches infinity. So if I put the value of alpha as 2 lambda n naught, so if we put this value we can obtain it as n equals 1 by lambda. Alpha can be written as 2 lambda n naught minus, again alpha can be written as 2 lambda n naught minus lambda n naught e to the power minus lambda, and t will be approaching infinity. So if t will be approaching infinity, so I can write it as 1 by e to the power lambda t. So as t approaches infinity, this value will approach 0. So if this value will approach 0, then we will be left with n equals 2 lambda n naught by lambda, and hence the value of n will be obtained as 2n naught. So this is going to be the answer for B part.